Hey everyone, and welcome back to another Explainer. Today we're unpacking a really critical intersection in our global climate system. Basically, what happens when natural, recurring climate cycles crash head-on into long-term planetary warming. We're looking at a world where these two massive forces aren't just sitting side by side, they're actively, dangerously interacting. So we're moving way beyond just asking, hey, what's the weather going to be like? And instead, we're tackling a much more profound question. Why do these risks compound to threaten our resilience in an era of unprecedented environmental change? Okay, let's dive right into this. Think about a strengthening El Niño, that intense band of warmth building up across the equatorial Pacific. But here's the absolute critical distinction we have to make right out of the gate. This El Niño, it's not happening in the climate of 30 or 50 years ago. No, it's developing on top of a planet that is already carrying significantly more heat in its atmosphere and its oceans. When natural climate variability meets climate change, the impact isn't just additive. It's not 1 + 1 = 2. We're dealing with a superheated globe where natural cycles behave entirely differently. And if you're wondering about the urgency of all this, just listen to this data point. The latest diagnostic from NOAA estimates there's a 97% probability that this strong El Niño will persist all the way through early spring of 2027. On top of that, they're seeing an 81% probability of a very strong El Niño developing late in 2026. So we're not talking about some fleeting weather anomaly here. We're talking about a persistent, powerful climate driver that's going to create urgent systemic risks across the globe for a really sustained period. To really wrap our heads around why these risks compound, here's our roadmap for today. 1. The new climate baseline. 2. The compound risk equation. 3. Cascading infrastructure threats. And 4, strategies for resilience. All right, starting things off with Section 1, the new climate baseline. I absolutely love this analogy because it perfectly captures the core dynamic of our current climate system. Think of increasing greenhouse gas concentrations as producing a persistent, long-term warming. That's your floor being raised. Now, El Niño, as a natural component of the El Niño Southern Oscillation, or ENSO, well, that operates on top of that floor. It temporarily kicks in extra warmth by shifting heat exchanges between the Pacific Ocean and the atmosphere. So when a heat wave hits today, it's starting from a much higher temperature. Those natural temperature spikes are literally superimposed on decades of human-caused warming. To give you a sense of just how elevated that floor has become, Copernicus reported that July 2026 was tied for the second warmest July globally. It was sitting about 1.47 degrees Celsius above the estimated pre-industrial average. In fact, if you look at the World Meteorological Organization's data, 2015 to 2025 were the 11 warmest years on record. And this right here is exactly why organizations and governments have got to stop treating historical temperature records as an okay baseline. Actually, scratch that. The past is literally no longer a reliable map for our future operating conditions. But hey, it isn't just the air that's heating up. The ocean is basically one of the largest heat reservoirs in our entire climate system. In 2025, ocean heat content reached its highest recorded level ever, and the rate of ocean warming has more than doubled in recent decades. Now throw El Niño into that mix. Super warm oceans are a massive deal because they heavily influence evaporation, atmospheric moisture, and how storms develop. So we aren't just talking about, warmer weather outside. We're witnessing a profound structural change to the entire global energy and water cycle. Which brings us to Section 2, the compound risk equation. Now here's one of the most widely misunderstood features of El Niño. It definitely does not produce the same outcome everywhere. The exact same global climate driver can create completely opposite extremes at the exact same time. For instance, forecasts point to wetter than normal conditions in the Greater Horn of Africa and Southern Europe, but simultaneously, they project drier than normal conditions across the Indian subcontinent and Australia. This paradox is incredibly dangerous for global operations. It means you absolutely cannot rely on a single, generic corporate climate strategy. You have to map your exposure geographically. Because El Niño could literally be flooding one of your supply chain routes while causing a massive drought in another. And this leads us to a crucial concept: compound climate risk. Basically, this is what happens when multiple hazards interact. We aren't dealing with isolated events anymore. We're dealing with combinations that produce consequences that are way bigger and way more complex than what our traditional management systems were built for. If your risk management system only looks at heat or it only looks at drought, it is going to completely miss the devastating impact when they happen together. Let's break down how this equation plays out in the real world. Extreme heat, dangerous. Drought, dangerous. Low soil moisture, also dangerous. But when these three conditions overlap, they supercharge each other. The dry soils reduce evaporative cooling, which makes the vegetation way more combustible. Water availability drops off a cliff, and suddenly, boom, you have a massive compound fire risk. We saw this exact domino effect serve as a brutal warning in Western Europe, which had its hottest June on record in 2026, leading to massive downstream effects on agriculture, dropping river levels, and extreme wildfire risk. So, how does this impact human systems? Let's get into Section 3, Cascading Infrastructure Threats. The largest business consequence of an El Niño event is rarely the temperature itself. It's what that temperature triggers. Let's trace it. Extreme heat hits. Right away, that creates higher cooling demand. Everyone turns on their AC. That demand creates a peak electricity load, which then forces equipment to be derated and puts severe stress on the grid. The end result? Total operational disruption. The initial hazard was just heat, but the actual real-world consequence was a complete failure of critical infrastructure. Here's another classic cascade effect. It starts with compound heat and drought. That immediately reduces water availability, which leads straight into severe agricultural stress and lower crop yields. So agricultural stress hits, and then what? You get intense commodity price pressure, which ripples out globally into widespread supply chain disruption. Again, these aren't just isolated environmental events. They're highly interconnected operational risks. This is exactly why El Niño and climate compounding have to be integrated right into enterprise risk management and business continuity planning. It can't just be a footnote in an annual sustainability report. All right, let's talk solutions in Section 4, Strategies for Resilience. The fundamental shift that organizations need to make right now is connecting seasonal climate intelligence directly with predefined operational controls. It's all about converting a weather forecast into an actionable management trigger. You have to evaluate these compound scenarios, like what happens when climate warming plus a strong El Niño plus extreme rainfall all hit at once. And you have to map this exposure specifically, from the asset to the hazard to the vulnerability, all the way to the control. A seasonal forecast should automatically trigger a predefined preventive action. No waiting around. To do this right, organizations have to aggressively stress test their critical physical assets. Can your equipment actually operate under temperatures that sit way outside historical design assumptions? You've got to look closely at cooling and HVAC systems, transformers and electrical infrastructure, water treatment networks, drainage and stormwater capacity, emergency generators. Climate resilience has evolved big time. It's no longer just an environmental issue. It is a critical, urgent asset performance issue. And please, whatever you do, don't just monitor El Niño in a vacuum. It's completely insufficient. The World Meteorological Organization expects interaction between this developing El Niño, those exceptionally warm global oceans we talked about earlier, and a positive Indian Ocean dipole. A mature climate risk dashboard has to monitor all of these drivers together at the same time. The goal isn't to predict the weather perfectly. The goal is to identify the precise moment when the probability of operational failure starts to creep up so you can act before it happens. So the next strong El Niño is developing inside one of the warmest climate states modern civilization has ever seen. The risk equation has fundamentally shifted. The challenge isn't managing climate change over here and natural variability over there. It's managing the intense, compounding interaction between the two. Which leaves us with a final, pretty provocative question that every leader needs to be asking themselves today. Was your organization actually designed to remain resilient when both of these powerful climate signals align? Because, as all the data is showing us, that alignment isn't some distant future scenario. It's happening right now. Thank you so much for joining me for this explainer, and keep learning.